Hello, my name's Pete Hurd. I'm a software developer. I've created this particular ebook called TDD Simplified in 5 Steps, and this is a screen presentation to actually go over this. So I do this as a talk in London and Reading, and this screen presentation will basically be going over it. So I can be found on my website, petehurd.com, or you can send me a message on Twitter, PTE Hurd. So let's start. So obviously when I do this talk, I usually ask the goals of the people that I'm doing the talk for. However, since I'm talking to a computer screen, I won't be able to ask goals, but I'm going to make the wild assumption that since you're watching this screencast, that you are actually interested in learning a bit about test-driven development. So basically, I'm just going to go over what my goals actually are with this particular video. I'm just going to try and go over 3 things, and the first thing I'm going to do is just briefly just establish with you exactly what test-driven development is. So the reason I do this is so that I've got just a very clearly defined starting point of exactly what test-driven development is, because there's always some confusion with regards to it. Some people say it's test-driven design, some people, or rather they call it test-driven design, some people test-driven development. So I'm just gonna just make that absolutely crystal clear on exactly what it is. Then I'm going to do something which often doesn't happen, but I'm going to outline the objectives of test-driven development. Now, it's important to realise at this point, these objectives are my objectives when I do test-driven development, and they are why I wrote this ebook called The 5 Steps to Simplifying Test-Driven Development. So the reason that I actually do this is so that you can see exactly where the ebook goes and where this particular course goes, and exactly the mindset behind it. And then what I'm going to do is I'm actually going to introduce the 5 steps. So I don't know how many steps we're actually going to get through, but hopefully we can get through the majority of them. Okay, so the way the ebook starts, and the way that I wanted to start this video, was to actually do some talk about the foundations. And so these foundations are things that we need to know in order to be able to implement the 5 steps in the book. So first thing is to actually describe what test-driven development is. So what is test-driven development? Well, first and foremost, what we actually do is we actually create code and we create tests. So a lot of people actually say, you must create the test first and then the code. And as a discipline, they are absolutely right, because that is the generally accepted procedure for it. However, my experience has been that although I do that now, and that although the people who are heavily experienced with test-driven development always do that, it can sometimes be useful to take the approach of creating code and tests at the same time. So I would not want to create very much more code before the test, but sometimes in order to just start the ball rolling and in order to understand where I'm going with the tests, sometimes I will just write a bit of code just as a prototype. As I say, I do it less and less, but at the end of the day, if this particular course is designed to actually help you to learn test-driven development, so I didn't want it to be too dogmatic in discipline, because I do personally believe that there's a way to start with this where you can start to build upon your skills as a test-driven developer. So I say basically at the start of the process is to create the code and the tests at the same time, preferably the test first, of course. The second part of this process is really about refactoring. Now, refactoring is an extremely important thing that you really have to do with code. The reason that refactoring is so important is because of the next boxes that are going to come on the screen. And they are clean code and clean tests. The whole point about test-driven development for me as a professional is to actually be able to hand over at the end of the day clean code and clean tests. I need to have the clean test because I need to be able to refactor my code, and in order to refactor my code, I have to understand that the code that I'm refactored into works. So I create this process, which is all that test-driven development is. It's a lightweight process where you create some code and you create some tests, you do some refactoring, and the artifact is clean code and clean tests. They, for me, are what I'm paid to deliver for my employer, my client, or whoever. That's the ultimate goal of that. Sorry, just bear with me just a moment. Right, so so basically that's the process of TDD. Okay, so basically what we're going to look at as well is the 5 steps. So we're just going to get a bird's eye view now of the 5 steps that are actually in the ebook. So let me just go back one. So the very first step that the ebook actually talks about is setting up the objectives. So these objectives are the objectives that you can use as a guideline in your test-driven development to actually say what's important to you when you're practicing this discipline. There's a lot of people out there that will say things like, best practice is this, and you should be doing this and you should be doing that. I personally think that there is no best practice. The best practice is whatever you choose at the time to be relevant for you. If you don't think test-driven development is relevant, you don't do it. If you don't think clean code is important, don't do it. There's no point doing stuff unless you believe or your team believes that it's actually important. So the most critical part of the 5 steps is to firstly is to create an objective and to actually state what your objectives are with regards to test-driven development. So the second step is a technique called layering, and layering is actually to do with how you identify the layers that already exist within your application. So we will come on to this obviously. So what you do is you identify the layers that already exist in your application, and then you seek to make them explicit within your application. Step 3 is actually decoupling your tests from your application. So as I'm sure you know, coupling in software is one of the biggest problems that there are, and so it makes sense from testing if we follow tried and tested software development practices. So decoupling is one of those steps that I recommend. And the next 2 steps, I don't know if we'll actually cover in this, but hopefully we will, so I've put them in red. Step 4 is actually what we do in it is we actually extract the benefits of BDD, behavior-driven development, and of integration testing, and we use those in our normal unit testing scenario. And the reason we do that is because this course is very much designed for people that want to start or restart test-driven development. So what we're looking to do is we're looking to find a minimalistic set of I'm looking to give you a minimalistic set of tips really, which is what these 5 steps are, and they are meant to take the burden off you having to learn too much. They're to help you get up to speed with test-driven development fast. They're really just to help you get going with it. So as I say, it's usually for people to stop or restart test-driven development. So we do look at behavior-driven development and integration testing, and we hopefully pluck out the high value stuff from those and implement those. And then the very final step in the process is framework separation, which is where I basically discuss inversion of control, and how basically we're not framework developers, we're object-oriented developers, and the most useful thing to do is to actually separate the framework code from the application code, and yes, so I go into that. Okay, so the very first step in the book is called identifying objectives, or more specifically, identifying automation objectives. And so basically what we do when we want to when we want to identify our objectives, as I was saying earlier, there's no point in starting this process unless we actually clearly know what it is that we're trying to do. So TDDs, like everything else, is a buzzword, and people love buzzwords. So when a project starts, everybody sort of rallies around, and they'll say, what are we using on this project? We're using TDD, or we're using using Angular, or we're using whatever. And all these frameworks and approaches, they generally get discussed, and people do them or they don't do them. But the way I see it is really what really the first conversation that you should have is in when you start any project is really, what are your objectives for that project? Obviously we know that working software is going to be one of them, but do we need maintainable code, and are we going to have lots of boundaries on physical infrastructure, and how fast do we want to deliver, and how much do we want to embed ourselves with the business and the stakeholders and the collaborators and all that things, and when do we want to release, so actually define what the objectives are. So that's the very first step. So the objectives that I'm going to recommend for the sake of simplifying test-driven development are 4 basic tenets, if you like, 4 basic fundamentals of this. So the very first one is that the unit test should be fast. And what I mean by that is that you should be able to execute all the unit tests that tell you if your software works, and that you should be able to do that, and they should basically complete within no more than 30 seconds, a minute. So the reason for this is so that it tells you that basically you can refactor. So as we talked about earlier, you need to be able to refactor. So you need to have your tests running fast so that your refactoring isn't hampered. So when you get to the end of a cycle and you want to know, and you've done some refactoring, you want to know if you've broken anything, you don't want to be sitting there for like hours waiting for these unit tests to pass. So you need to be able to know immediately if you've broken something. So I say that the objective of simplifying test-driven development is to make sure that your unit tests run really fast. The second thing is that they should be readable. You should be really able to understand them and be able to read them easily. You should be able to read your unit tests easily. So a lot of the time what happens with teams, they just start TDD and they just go off for it, and they create lots and lots of tests, but they aren't necessarily they don't necessarily have any value if you can't read them. If you can't read these things, then there's not really much point in having them, because you don't really know what they're testing. So one of the objectives is to make sure that all your tests they are clean. Like we said earlier, we're looking for clean code and we're looking for clean tests. Also, they need to be refactorable, so you'd need to be if the whole point of creating tests in the first place is so you can refactor your code, then your tests in order to do that refactoring, then they need to be refactorable. And so we come onto this later, but this is to do with coupling, how you couple your tests to your actual logic. But this is, for me, it's definitely an objective, is that I should be able to refactor the code, because that's the original reason for the tests in the first place. And the other thing is that is to do with coverage. Now I've put one-to-one coverage here. Just a question I usually ask people is like, what is your target coverage for tests? Now, a lot of people will, sort of say 80, 90%, but really when you think about it, your coverage for a test should be your target coverage should be 100%. Are you going to reach that coverage? No, you're not, but it doesn't change the fact that you should always aim for what you're aspiring to achieve, not what you think you will achieve. So you really want to go for as much coverage as possible. Now, the two ways to think about this are, you can either put a number on it. What I prefer to do is I prefer to say, I want to have a single unit test for every single thing that my software does. Now, there are going to be some situations, getting very down to low level things where you're not going to be able to fulfill that aspiration. However, what we're aiming for is, one test for one feature. That's the ultimate. That's the ultimate goal. So basically, you will no doubt struggle with test-driven development. Everyone does when they start doing it. But the thing really I usually do with test-driven development is I have like this thought experiment which I go through in my head, which is designed to keep me motivated and to keep me on target with it. And the way the thought experiment goes is as we've already established, I want to deliver clean code. As a professional, I don't want to hand over a mess. I don't want to hand over spaghetti. So in order to deliver clean code, I don't write code off the bat that's clean. It's got design flaws in it. It's got funny things in it. And so in order to get it to deliver that clean code, I need to refactor it. And I have to refactor it. That's not that's out of the question. And if I'm going to refactor it, I don't want to break it. There's no point in me trying to do something if I'm then going to put the software further back than it was when it started. So I have to have unit tests. And those unit tests tell me whether I've broken it so that I can know if my refactoring was successful. And in order to refactor, as we've already discussed, we need to have the tests that run fast. We need to decouple them so that that ties in with the objectives that we said earlier. But really, if I need clean code, I need to refactor, and if I need to refactor, I have to have tests. I can't not do test-driven development when I run through that thought experiment. It just wouldn't be professional of me because I cannot convince myself how I can't have a full automated test suite to go with my code that basically doesn't I need to practice test-driven development because I need to have one-to-one coverage, and I need to basically have unit tests that will cover everything, so I can know if I can refactor so that I can deliver clean code. I mean, it just makes logical sense to me. So that's what always keeps me on target with it, and it's been a useful thing to sort of do because it's helped me to keep honing my discipline and learning this fascinating skill. So just to recap on that very first section then, which was observing objectives, there is no point steaming into anything unless you identify your objectives with something, and the same holds true for test-driven development. So what we actually did is we actually went over the four facets of a robust automated test suite, which was they're fast, they're readable, you can refactor them and get one-to-one coverage. Now that was of automated tests only that we talked about, but what we're doing when we do TDD is we're trying to have a process that will give us automated tests to go with our code. That's all we're doing at its very simple level. Okay, so the second part of the ebook actually talks about this concept of layering, and before we actually discuss layering, let me just. Sorry, I just don't know. A swig of coffee. So basically, before we actually talk about layering, the thing that we need to talk about before we go into layering is the concept of a finite state machine. So I would usually ask here, who knows what a finite state machine is? I imagine most people would know what it is, but I learned about finite state machines at university and then never really came across them until I realised something about test-driven development which reminded me of the finite state machine. So we'll start with a hard example here, which is a car. So I'm going to say that this is a car that happens to be sitting outside on a drive, and at the very moment it's actually in a state of being idle. Okay, that is the car, is the object that we're talking about, and the state it's in is idle because it's not going anywhere. Now, there is an operation that I can perform on that car to make it go somewhere. What's the operation? Probably going to say driving, but I'm going to be more mathematical and say it's to accelerate. So we are idle is our start state. Accelerate is the process that we go through, and then our end state is crash, maybe. Hopefully not. It's probably going to be driving. We'd have to drive before we get to crash anyway, unless you're really bad at it. So basically, this car has these three definite states. It's got idle, accelerate, and it's got driving. Now, when you think about an application, especially an object-oriented application, applications hold state by using variables. So regardless of whether you're functional or OO or whatever, at some point usually there'll be an assignment to a variable, and that means that they hold state. When you when you hold state, that means that you actually start to become this state machine. And so the way that I usually think about a piece of software is it's sort of state-based in terms of we have input models that go into it. Then we actually execute some code. So in the OO world, this is functions in functional world as well. But in an OO, we actually execute functions, which is our code. I'm going to call this here. So we have our input model, our input state, and then we have our code, and then we have output models, which sort of ties back to what we were talking about with the car. So we've got idle, accelerate, driving. Then in the application, we've got input models, then we've got our code, and then we've got output models. So our input model might be some sort of model that's attached to a form, and then our code is something that processes that form, and then our output is something like, a model is a very simple data structure with a message on it saying, yeah, thanks a lot, we've got your order on the screen. So that's basically how that works. So if I was to write a unit test, it turns out that unit tests actually execute code as a state machine. So in order to, I don't know if you've ever seen this thing before, this arrange, act, assert, but this basic idea is that you set something up, you act on it, and then you assert it at the end. Well, this ties very, very nicely into our idle, accelerate, driving, because we have a start state, then we do something, and then we are in another state. So we have this test, arrange is our start state, that's when the car is idle. Then we act on it, so we accelerate it, and then we assert that the car is driving. So that's our three states, and that's a fundamental thing to get with test-driven development. Every test starts in a state, it operates some code, it executes some code, and it ends in a different state. If it doesn't end in a different state, it hasn't worked because your code isn't doing anything. So when you're actually doing test-driven development, you have to really think about locking down the inputs to it so that they're still. And what I mean by that is things like dynamic ID generation and time. If you are starting to do test-driven development, it's important to actually lock those things down and actually use dependency injection to inject those in. So we start, we accelerate, and then we have our end state, which is driving. So I just want to have a look now at some code. I call this WTF code. I'm sure you know what WTF stands for. Yeah, a bit more than that. So sorry, I'm just looking through my. Just making sure that yes, right. So this code, it's heinously ugly. This code, it's really bad actually, and that yes, that's a judgment. We all make judgments on code, but yeah, I had to maintain this, and yeah, I just really got my nerves because it's so bad. But it basically what's going on here is that we have this thing called UDF. So basically, I'll just put it in context. What it is actually a map, and the map is like a geospatial normal sort of map thing, and it has like features on the map. And it has pins where these features are, and if there's loads of features in one place, the pin needs to show the number of features at that place. So it's a bit like, I've got several water things or wells or something all within, a kilometre, and then just, because it can't show them all in a kilometre because you'll zoom so far out, just show a pin on the map with the number of water wells, and that'll be like a layer on the map. So the very first thing that happens in this is, you can see here it's got this UDF service, and it's actually getting the features, and it's getting that from a service. And then what's happening is it's actually making a decision on the thing that comes back from that UDF service. It's actually making a decision about that, deciding on whether it's going to draw this pin on the map. And you can see that with the return statement there, which is basically a guard statement. which are quite useful, by the way, if you do want to just exit out of the loop. I never used to like them before until it's got explained to me in a certain way. But anyway, so yeah, they're pretty good. So basically, what happens is that the model is downloaded, a decision is made on that, and then what happens is further down we can see on about line 19, what they're actually doing is they're actually pushing these data structures onto an internal array, and the reason they're doing that is because later on in the application needs to have it on its own array called OL features. Okay, so it's nothing to do with the view, it's nothing to do with the data structure that come in, it's to do with the internal workings of the application, it's to do with the design of the application, that it needs those. Okay, and then right at the end we're doing stuff for the view. We can see here line 25, UDF feature.OL feature. This UDF is basically a reference that's then going to be bound to a view, and so what we're doing is we're creating a pin for the future, keep reference open as object that represents this, so they're setting up references. And also we've got this thing, the feature count here, and that's the thing that's actually, that's the thing that's going to be on map. So basically everything at the bottom there is to do with the view, everything in the middle is to do with the design of the application, everything to do with the top is to do with data transfer. So you can basically see that we have three independent layers or models, types of models, categories of models that are going on here, categories of data structures. We have something to do with data transfer, we have something that our application needs later on the line for some other processing, and then we have something for the view. And a data structure that lives in the view is called a view model. Okay, so lots of people, say, oh, well, view model, I use an MVVM, MVVC. It doesn't matter. The point is, if it's a data structure that lives in the view, it's called a view model. Now, this hasn't identified those particular models. However, the point about this code is that those models do actually exist within there. Regardless of whether we've identified them, they exist in there as a concept. You cannot get away from that. As soon as you start to write code, models exist. The choice is whether you put that in its own object or you keep it in big inline functions. And I'll let you guess whether I'm a fan of what you see in front of you. So the problem. Now I'm going to answer this thing that I just said just there. I'm going to tell you whether I'm a fan of it, because the problem with what we've got here, with what we've got on this screen here, is you see, if we want, from a testing perspective, and from an architecture perspective it's not cool, but from a testing perspective it's also not cool, which is obviously what we're discussing. Because what we've got here is, in order to test something that lives in the view, we've now got to access something called scope, which is an Angular thing, an Angular JS thing, and basically it's a type of global variable. But let's not worry about that. The point is put on the scope is not the point here. The point is that there's no context. We've just got scope.featureCount. What does that mean? Is that needed? Is that a data structure thing? Is that needed by our application? Is it needed in view? You just can't tell by looking at that. So your test is now not easy to read. It doesn't match Objective 3 or whatever it was from our very first step. So it's obscure, and obviously the last thing we want to be doing when doing TDD is to be obscure. So what is the solution? Well, as we've already discussed, the solution exists whether you like it or not. What we're actually saying is that we're dealing with a state-based system, and we have a defined set of inputs and we have a defined set of outputs, and the things that come in are our data transfer models. Then we have our code with its own suite of models or data structures, and then we have a thing that pops out at the end called a view model. Now the bit in the middle, depending on how big your application, will just get bigger and bigger and bigger, but even with a single page application, minimum you're going to have is 3. You're going to have data transfer, you can have stuff your application needs to do, and then you're going to have stuff for the view. So the solution, or rather the solution to this problem of putting everything in one long script that handles everything from regards to TDD, which turns out to be extremely obscure if you want to do TDD. The solution to that is to get straight in your head what the layers are in the application. And so what I've done here is I've actually refactored that code, and what we have at the top here is on the scope I've said UDF list view model. I've been very explicit with it. I've said, right, this is the view model. There doesn't need to be any argument about what's going to go in the view model, because it's a model that's for the view. It's very clear. If anybody sees that, they know it's not going to be data transfer, it's going to be something else. It's a model that goes in the view. You can't, it'd be difficult to be any more explicit than that, apart from putting it actually in the view. But we'll come to that in a bit. So what happens is we define our UDF view model, we then do UDF service.get features, and then we go through and we just go down here, and we sort of populate, we populate the view model, and we push some things onto it. And really the main point here is that we're actually, we've actually populated a view model. So let's just have a quick recap on exactly what we've done here, right? So we saw first of all how long, ugly scripts, apart from the fact they're ugly, they have in them the concept of data structures and models exist. And we saw that if you leave it like that and you're not clear about where the models are, then it becomes obscure, you get vague unit tests. So what we did is we actually refactor the code, and then we get a unit test that reads easy. So we know now that test checks that the third feature is updated with the total features count is to do with the view model. We've said what it is, and then we've said what it's actually updating. So the one up top is vague, and the one below is obvious. And so apart from the fact it's good software engineering practice, to be explicit about what's going on, the point is that if your tests need to be readable, then really you have to start to split things into layers, because it's just not clear from when you look at tests exactly what's going on. So let's just have a quick recap on what we've talked about here. We've talked about the fact that our data transfer objects come down the wire. We then manipulate them, then we put them into view models, and then we return view models to the view. That is probably the most important thing behind layering. The most important thing is that you are getting something, you are manipulating it, you are putting it into models. And if you take one thing from this step that I can recommend with regards to test-driven development is to realise that there is quite an extreme overhead. There can be quite an extreme overhead with testing view sometimes, because you have to start to dig through HTML, you have to worry about synchronicity issues, you have to, if the view ever changes, the HTML in it changes, stuff like that, you'll break the test. So to test a view directly is quite an expensive thing to do. However, there's an abstraction that lives behind the view, which is the data structure that is exposed to the view, and that's called the view model. So if you follow this pattern, you use view models, you do two things. The first thing that you do is you actually remove the need for your view to test your view, and it means that your view can be simple. So basically, one of the things with views is that they tend to be really, really complicated. We have like if statements in them, we have for each loops, and sometimes they start to do business logic and they start to format things. Don't bother doing that. Just do everything that you can. Do formatting, render off strings, do for loops if you can. Do it all in the view model. Do all the loading of the data. Do all the preloading of it, and bundle it up and get it ready, and just deliver this fully prepped data structure to the view. And if you do that, it will make your life with automated testing easier and with test-driven development easier, because you will be able to visualize exactly what you're testing. And that will obviously make it easier for people coming across and reading your code later on. So the third thing that we actually talk about in the ebook is to actually decoupling the unit tests from the implementation details. So the first thing that we need to understand is we need to just get an appreciation of what coupling is. I think it's easy as a software developer, to just sort of assume that we know these things, but it's something that we can forget every now and again. It's quite possible if nobody asks an interview or whatever, we might just forget exactly what coupling is. So let's just go over it one more time just to make sure we know exactly what it is. So basically, I've done some code here, and what we have is a JavaScript function constructor, if you like, called the hobby updater. And the hobby updater has an internal reference of a hobby, and it exposes a function called update, and it will go off and it will update the person. But the problem is it will only update the person if the person has a hobby, and if the person has a hobby, then it will assign the internal reference to running as the person's hobby. Now, what is the problem with that? So I'd usually ask people what the problem is. But given that I'm just giving this talk on my own in my room. That won't happen. So basically, the two reasons really why there's two reasons why this particular code is a problem. The first one is that it creates too much interdependency from the hobby updater to the person, and what this is known as is inappropriate intimacy, which I love that expression because it really tells you, why does the hobby updater need to know if the person has a hobby? The hobby updater is simply just updating something. It should just be assigning something. The very virtue of the fact it's got an if statement means that it's interrogating something. We never asked the hobby updater to make that decision. We only asked it to do something, not to ask something. And so it basically has too much knowledge. So we've got too much interdependency and we've got too much knowledge. So there's a solution to this, which is called decoupling. And decoupling turns out that what we do is we actually say, in the hobby updater, we are now not going to ask if the person has a hobby. What we're going to do is we're just going to update the hobby. We're going to say person, update the hobby. Now, this isn't a particularly great code example in terms of overall design. You probably could argue that, well, why is the person updating the hobby? The person should just be a person, state structure, whatever. But the point is this is just an explanation of coupling. And when you start to see if statements in functions, and those if statements asking questions about other objects, alarm bells should be ringing because that is coupling. And this particular type of coupling is inappropriate intimacy. It's also known as a train wreck. And so what we have there at the bottom is actually less coupling example. So the difficulties, as we've already discussed here, is that from a comprehension perspective, it can be very difficult. If we just sort of go back to that, from a comprehension perspective, it can be really difficult to when a developer is reading this code, if they want to know what hobby updater does, you've now dragged them into the situation when they read the update method, they now have to know if the person has a hobby. So they now have, in other words, they have to know about two objects, not one. They have to know about the hobby updater, and then they have to know about the person. They have to know, has the person got a hobby? And if it has, it's on a hobby, and that's just, the person just wanted to, because the person was fixing, say, a bug in the hobby updater, and you don't really want that developer. I say person, the person is the object. I'm talking about software developer here, which is still people, obviously. But so basically, it's just making it difficult. It's difficult to comprehend. It's just more difficult. It's not difficult, but it's more difficult to comprehend if you're dragging the person into understanding the interface of the person object. And so basically, that's the one thing. And the other thing is modification. The other big thing here, I forgot to mention actually, is it makes it really difficult to modify the hobby updater, because when you have lots of dependencies between two objects, a change to one will force you to change the other. Now, you're more likely to change things like the has hobby and the hobby variable than you are with just the update method that updates the hobby, because you've buried away all those little rules about does it need to do something, has it got something, away in a function. So if you have less coupling through the function, so therefore you're reducing the chance that a change to hobby updater will need to change the person, and likewise, so you've reduced the dependency between the two modules by making the interface between them simpler and hiding the person's data structure from the hobby updater. Both of these things ultimately really come down to a concept of the reason that this decoupling is so important is to understand is because if decoupling applies to software. So if it applies to software, it also applies to tests. If your tests are coupled to your code, then you make them harder to understand, you make them harder to modify, which comes back to our original objective in the 5 steps of easy to understand and easy to refactor. And so what you actually do is you end up devaluing the unit test code base because you've coupled. So so basically, the thing that we say is to basically, decouple your tests from your implementation details. So we also call this outside in test-driven development. So we just look at the end product. So we do things like look at view models predominantly and just check that the view model is in the right state once we've invoked all of our internal code. So I just got this thing off the internet, which I just thought was brilliant. It's this guy planking a lion. I don't know, it's probably Photoshop, but I thought it was pretty good. I don't recommend trying this with a domestic cat. I've actually already tried it, and he wasn't too happy about it. So yes, that's what I want to show you. So obviously, yeah, we know that coupling is a problem. So I just want to show you some actual tests here where we've got coupling going on in the test. So basically, this is a classic example of coupling. So we've reiterated what software coupling is. We just have a quick look at test coupling now. So we've got at the top here, we've got delete should delete request to the API. So what we've got is on line 4, we've got this HTTP backend object, and this is an object that actually handles sending and receiving HTTP data. And then we've got you've got an API object which handles the deletion of the data, and the API object talks to the HTTP backend, by the way. So we set up a stub, a spy on the HTTP backend, and we've said, look, when you get this delete request, then send a 204, right? And when the 204 is a delete response, HTTP delete response. And when you get this response, the way that we're going to check the final state in this test is we're going to expect it to be empty. And that actually means that the request was successful. But in order to understand this test, I have to understand about deleting HTTP object, which I don't necessarily want to know. You have to understand the response codes. Then I have to understand my API object. And by the way, my API object is only used by my application. It's not used by the outer loop. It's not used by the views. It's not used by anything else. So I'm getting a very, very tight coupling here. I'm looking directly into the architecture of my application. I'm looking directly into the structure of how it works on the inside. This is like checking, what's the hobby? Do they need to assign the hobby? I don't care about the API because the API is just a utility class that my application uses. And what's actually going on here is saying, well, if the response is equal to empty object, then yeah, that's been deleted. But why? There's no attempt to explain why that particular empty object is a delete object. Well, it turns out that because it's a promise that when it's an empty object, that means that it's successfully completed. But like, who cares? I only care about when you deleted something, did it delete, right? So if you contrast that with this highly coupled function with another function which is less coupled, and that is basically sort of doing a similar thing, but what it's saying is if a user at configure that's a typo, and goes back, then cancel will delete. Well, that's fairly obvious. That's written in like natural language for starters. So it's easy to understand. It's saying spy on the HTTP delete object, go back, cancel. Oh, by the way, expect delete to have happened. So it's very much tied to the outer loop, and it's not involving itself firstly with promises. It's not involving itself with response codes. It's simply saying go back, cancel, check that it deleted it with a HTTP command. So there's less coupling, and so that makes it easier. For me, it makes it easier to understand because it's a use case based test which goes through the process of doing stuff at the domain level. And by the way, this router wizard object is something that's exposed right on the very edge of our application. It's something that the view will talk directly to, because the way that this actually worked is that this was actually an application that had it was one of these wizards where you step through something. And so it's very much a visually oriented. That router wizard, the reason it's called a wizard is because it helps the person. And that's what presumably what wizards do, help people. So it actually steps through the application, and then it actually deletes. So it deletes that off there. So just to recap, basically on this, with test-driven development, think about decouple, decouple, decouple. Okay, so you really, really want to think about decoupling. If it's a bad software engineering thing to do, it's going to be most probably bad for testing, because testing is just software engineering at the end of the day. So we've learned how if you don't decouple, then people are dragged into this comprehension problem where you force people to understand what's going on at the lower level. In the code example, we saw it's the hobby. In the testing example, we saw they had to understand things about HTTP and stuff like that, which just isn't not HTTP, about promises. I still get confused with promises. I'm a JavaScript developer 2-3 years. Promises are not the easiest thing in the world to understand. They've got a complex API and it's functional, and they do callbacks and stuff. I don't care. I just want to know it's deleted. So So basically, just decouple. And basically, when you decouple, you make it easy to modify. Otherwise, you can end up devaluing your code in your test. So these do hark back to the original objectives. If you decouple, it's easier to modify and it's easier to refactor. So they're in line with our original objectives. So the very final step here, so we might get through all of them actually. So step 4, final steps, 5 steps, not 4 steps. So the very final step is extracting the benefits of BDD and integration testing. Now, I don't know if people are using BDD. I've been in lots of BDD places, and so they claim to be BDD, but what quite often happens, and it's a very, very common thing, is that people think BDD means over the web. It doesn't. BDD stands for Behavioural Driven Development, and the core premise of BDD was that you get this thing called a ubiquitous language. And the whole point about BDD, the guy who created it, Dan North, his name is, he created BDD when he was working for ThoughtWorks, and he created BDD to teach TDD, because what he said is that everybody was doing this thing that we spoke about in step 2 not to do, which is coupling. And so Dan North sort of did what I did, and he created BDD as a thing to simplify TDD. And I guess I created the 5 steps to simplify TDD, and they're sort of doing the same thing. It's just a different way of perhaps doing it. I guess getting back to square one, because although he created TDD was there, he did BDD to simplify TDD, and what I've seen is BDD has almost become more complicated on top, because I think people have misinterpreted what BDD is, and BDD is just doing unit test-driven development done properly, and these are his words, done properly, with this ubiquitous language. What BDD gives you is this whole this very nice tapestry of buy-in from business stakeholders and various other people involved in organisations, because you use a verbose syntactical syntax called the Gherkin language, and the Gherkin language turns out that it's pretty good because it describes the tests in terms of natural language. So instead of a test saying, when I do a HTTP call, I get a promise, and then I do this, and I unfold somewhere else, and I do all this stuff, and you think, don't care, just want to know if it works, just want to know if it deletes the damn thing. Instead of it doing that, BDD actually says, hey, when I go do root to wizard forward, and then I go back, and then it deletes, boom, done, easy to understand. So you get that benefit of a ubiquitous language. So step 4 is to understand what it is about BDD that's so special, and the other thing is to understand what's so great about integration tests. And the thing that's great about integration tests is depth and coverage. When you invoke the traditional mindset of a unit test is that a lot of people will just say, I'm just gonna test one single function here, and I'm gonna test everything that goes in, and I'll test everything that comes out, and I'm a functional programmer, and that's what I do. But the reality of it is that by the time you finish testing that function, you, apart from the fact you're coupling when you do that, you then might want to put 2 things together, and you have misinterpreted how the messages that get passed from one function to another function. And as soon as you forget that, you will forget that in your test. And if you miss that in your test, you'll have 2 tests passing, one that tests function A, one that tests function B, and you'll have a space in the middle, like a Venn diagram without the middle bit, where you missed what you actually wanted to test. And you don't get that with an integration test, because your integration test drills all the way through. It does all the functions. It takes a feature and it goes boom, 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 and it does all the functions in one go. And then right at the end, it just checks something right at the end, and it says, did you execute properly? I'm going to start you in a state. I'm going to process you, and I'm going to end up in an end state. And were you in the right shape at the end? And that's the great thing about integration tests. So what we actually let me just go a bit ahead here. What I just wanted to show you, I'll show you an example. So the reason that this step exists is to say, well, what if we could extract the benefits of BDD, the ubiquitous language, and the depth and coverage, positive aspects of the integration test, but do it with our normal testing, which is totally possible, which just means that we have to bind to the outer loop of the test, we have to invoke the code, we have to put test doubles in the right place to stop it from doing I/O and interacting with a physical environment. But we're going to get a lot of the benefits of integration tests. Now, we're not actually going to do integration tests full on, right? The reason for that is because integration tests are slow because they have to perform I/O. They have to do things like they have to make a physical network call. They have to physically load something off disk. Now, one of the objective of the 5 steps is for speed. Well, we can't have speed and be doing I/O. That's silly. As soon as you start doing I/O, everything slows down. So what we need to do is we need to say, well, what are the benefits integration tests gives us, and can we implement that in our normal TDD workflow? And it turns out we can pretty well. We aren't going to get all the benefits of doing a network connection, but we're going to get a lot of them. And that's why it says here it's the 80-20 rule aspect of this, which, if you do it like this, you get 80% of the benefits for 20% of the effort without having to do all that setting up physical infrastructure and stuff. So an example here is a little module called the RDP gateway. And the way this RDP gateway works is that a user clicks, they actually click on a button, and then it will go off and get a one-shot web link, and it will return that one-shot web link to the application. And once it's done that, it will redirect the user to that one-shot web link, and that means that it's basically a tokenized login, so to speak. And so what we see here is that the very first thing we need to draw attention to is the ubiquitous language aspect. So what I've done here is I've written a test which is extracting the benefits, one of the benefits of BDD, which is the ubiquitous language. RDP gateway will redirect user to web RDP location. I haven't written anything about promises. I haven't written anything about HTTP because we don't care. What we care is that the RDP gateway will redirect the user to their web RDP location. I go to somebody in the business. Arguably, they need to know what web RDP is, and that's the one thing they will need to know. But that's domain-specific knowledge that they most probably will know. And I could go to hand that to anybody in business, and they go, well, yeah, this thing redirects them to the web RDP location. I don't know what the web RDP location is, but I know that's what it does. And so this is what I'm saying. So what my tip is to basically is to take the unit test, and is to actually just write the unit test in plain natural language at the top, and then therefore you get the benefit of BDD. The other thing as well that we've done here is that because we've essentially decoupled, and this step essentially builds on this particular step in the process actually builds on what step was it? The decoupling step. Because what we're saying is we're trying to get the depth of an integration test. And in order to get the depth of an integration test, we actually need to decouple. And so what we've done is we've actually just invoked our public API code, the RDP gateway. Again, the RDP gateway is something that's very close to the view in our case. It'll be up near the view model layer. And so what we actually do is we connect to the RDP gateway, and then we expect that basically the URL transporter, and guess what the URL transporter does? It takes us to the URL. We invoke the RDP gateway, connect to this workstation, and then the URL transporter will take us to this end location. So it's very much written in natural language, and we've actually performed like an integration test. We haven't got deep into this and gone, oh well, what status code is it using, and what network connection is it using? Oh, let's set up a port. No, so we don't care about that. We just want to know, does it redirect them, right? So that's how we simplify this part of the process. So we're on. Let's just have a look. Oh, sorry. So I've got another couple of slides. Yes, right. Okay. So BDD at the top, integration at the bottom. So just to recap on this section, this was step 4, and this was extracting the benefits of BDD and integration testing. It relies upon the 80-20 rule. So you are getting 80% of the benefits with 20% of the focus, which is nicely demonstrated in this picture. So you are basically using the ubiquitous language of BDD, but you're going to say that all your unit tests are like little mini integration tests. But what you're going to do is you're going to use test doubles to stop it from doing I/O. So the final step from the ebook is to do with a problem that is particularly important when you're just designing software anyway, but is also really important with test-driven development. And it's basically to do with separating your application code, so the code that deals with the domain problem, from the framework code. The thing to realise about a framework is the framework was created by someone else, and they are extremely useful tools, but they are just tools. So when someone creates a framework like Angular or UI Router, which is another framework inside a framework, they will create that framework with their own interfaces, because they're trying to solve a particular problem. And so it's really important to realise that our application has its own interface, because it has its own requirement. And so what we really need to do when we create an application is realise that a framework is actually a separate application. And because it's a separate application, we need to be very careful about keeping it at arm's length. It can be very difficult with frameworks because as you're stepping through code, if it's not clear where the framework ends and where your application starts, you won't know whether the problems are in your application or in the framework code. So, and the way we solve this is with something called inversion of control, which you may have heard of. So to start with, I just want to have a quick look at this, an example of where mixing framework with application code is really a problem. So what's going on here is at line 2 we have a function called watch, which is an Angular function to actually watch the result of a function which is basically being invoked inside there. And what's actually happening is, you can see on line 4 there, we're actually returning an evaluation of the string which is kept in a property called OL_center. So every time that OL_center, the string that represents that function for OL_center is evaluated, it will trigger this watch function. And basically what this watch function does is it passes the element, the property that comes back from that particular function into the next function, which starts on line 6. And what happens is what it's expecting is an element. So basically the reason this happens is because every time something changes on the page, an element is passed into the second function. And then what happens is on line 8 to line 10, we actually ask that element, are you an instance of an openlayers.long_lat, which is basically, openlayers is a framework, it's a mapping component. So just to explain to you actually how this mapping component works, the way this actually works is there's a map on a screen, and the user moves the mouse around on the screen, and when they move the mouse around, Angular detects that mouse move and it actually invokes this watch function and it passes the element. So the whole point about this function was that you're actually able to hone in on when you hover on an element on the map, it will actually center it. So what it's doing is actually saying, if it's an openlayers item, then actually center the map. And you can see where it says center the map on line 12. So basically that's the way this particular function works. And you can see here that really the logic behind it is basically saying, the reason it's asking is it an openlayers object is because an openlayer object, you can actually center, the business requirement was actually that you could center the map on that openlayers object. And so what we're actually doing is we're actually saying, if you can center on the object, then actually center on the object. But you can see here that we're actually interrogating the openlayers framework, and we're pulling out all sorts of information in order to see whether it is centerable. So there's two particular problems that this code actually presents us with regards to testing. In order to test this, we have two options. So just actually looking at this code, the two options to actually test this code are to, firstly, that we actually, if we want to run this function from a test context, we actually use openlayers. But in order to actually use openlayers, we'd have to do a lot of test setup stuff in the test, and that would be very complicated. And the other option is that we actually begin to use test doubles to stub out the openlayers code. But that's also quite complicated, because then we need to understand all of the interfaces that those objects implement. You know, we need to decide what we're going to return for the long_lat property. We're going to have to decide what map .set center should do, etc., etc. So it can, because we don't own the interface to the OpenLayers framework, that's going to get really complicated when really all we want to do is check that this function does actually center the user on the map. So basically, as we've said, we can either invoke the framework code, which is too complicated, or we can stub the framework code, which is also too complicated. So there is a solution to this, and this solution, when you actually write it down, looks like this. And we can see here that the scope.watch function is watching a function called centering, and what it will do is it will keep evaluating that centering function. Every time the return value from that centering function executes, it will then invoke the function afterwards, so on line 3. And so basically it's doing no different to the code that we saw before. So it'll basically invoke the code on line 3 and it'll pass in the element. If the element can be centered on, then it centers the map. So you can see here, because we've actually, instead of using the framework code on this watch function, we've actually used our own code, and we've given it a very clean interface. That function is now a lot easier to read, but it also becomes a lot easier to test. And the reason for that is because we own that interface. So you can see here, I've actually written a unit test on here, and because we've actually created our own objects, so we're testing our own objects here, between line 2 and 7, it is actually much simpler to set up. I can tell you that with OpenLayers code, we would be doing a lot more than 5 lines of code to actually set this up. So basically what this revolves around is inversion of control. This is what we've done. We've inverted control. So the idea is that in the real world scenario, we wouldn't be using lines 2 to 7 there. We would actually be using real world objects. And those real world objects would actually have an instantiation of OpenLayers in it. And so the OpenLayers framework would actually be wrapped up in a dependency that we inject in at runtime. So just to recap here, what we've actually done is we've actually taken out the framework code and we've used our own code. So we've removed the source code dependency to the framework. And then what we're going to do is we're actually going to wrap that code up in our own code at runtime. But for the unit testing purposes, we're going to use test doubles, and that's what we've done here between line 2 and 7. So we've actually overwritten those objects with things that we can use to put our test into a certain state, as we talked about earlier in this screencast. It's all about checking state. So we've actually set our test up in order to lock it down to a certain state to begin with. And so basically that's the solution, and that is basically the fundamentals of inversion of control. And inversion of control really should be used, it can be used extensively in order to separate your application code from your framework code. It's a really, really useful technique to do that. I use it all the time in order to keep test code simpler and to keep application code simpler as well. The last thing you want to do is to force people to actually have to understand frameworks when really they just want to debug your code. So basically, here's a little image that I thought was interesting. It's from Minecraft. I love the way on Minecraft you can basically find anything. Everybody has built anything on Minecraft, and when I typed in inversion Minecraft, this is what came up. It's a little house that's upside down, and if you can see that. But yeah, that's pretty cool. So just maybe a little helpful reminder there about inversion of control, helping you to reduce complexity with your unit tests when implementing test-driven development. So basically, the most important thing is to keep the application code separate from the framework code. The last thing you want to be doing in unit tests is having to understand the deep complexities of a framework. Frameworks are really, really useful, but they can become very, very complicated, and the last thing you want to do is be tied into that complexity. You just want to set up a unit test that tests your code, to test the code that you've written. Presumably the framework developers would have already unit tested their code. It's not necessarily your problem to do the same thing again. Okay, well that's basically the 5 steps that are in the book. This is usually the last slide that I close on. Basically we just get a high level view here on basically the whole 5 steps. And so we saw at the start of this presentation how the first thing that we got to do with test-driven developments, if you're using the 5 steps as a baseline to to learn and apply test-driven development. We saw that I've recommended four objectives here, and they are that the test should be fast, they should be readable, they should be refactorable, and that you should have one-to-one coverage. That's one test to one feature. And we went through 4 steps that each in their own right cover at least one of these points. So in step 2, we saw that we layered the application, and we did that by introducing models that already exist but often aren't clearly defined. And by clearly defining them, we can actually create unit tests which can easily pinpoint exactly what part of the application we're testing. This goes hand in hand with our state-based approach to testing. We then looked at step 3, which is important again for all software, and that's decoupling. If decoupling in code is good, it's also good for tests. We do the decoupling using an outside-in methodology where we close the public API of all of our code, and we expose it with just small functions, and that allows us to have code that's refactorable, which is obviously a key component, the key reason why you would do test-driven development in the first place. There's no point doing test-driven development unless you can and will refactor your code. The fourth step was to get the benefits from BDD and integration testing. So integration tests are deep and BDD tests are easy to read, and this is sort of related to coupling and it is sort of related to layering, but really what it gives us is it gives us an element of comprehension in terms of BDD. Anybody can understand the test if it's in natural language and not tied to low-level implementation details. And we also can see that with integration integration tests are very robust. And finally, the final step 5 was the framework separation, probably the most important, perhaps most underrated thing with all development. It's really good if you can take off your I am a C# developer, I'm a JavaScript, I'm a developer hat. If you can take that off and talk as a pure object-oriented programmer, then you begin to realize that really frameworks are just things that we use, and that we are actually developing object-oriented programs that model the real world inside code. And a key way to make better code is to actually separate the framework from the application logic. The application logic describes the problem, the framework describes another problem. In AngularJS speak, it just renders views. And so it really should be treated as a separate application, and that will help you to reduce complexity, and that will help you to write tests that are less difficult to set up and less complex, and that helps us with being readable, which is a critical component of creating a good unit test suite. Okay, well that's everything, and that was TDD simplified in 5 steps. We've probably ran slightly over the intended hour. My name's Pete Hurd. You can contact me on Twitter, PTEHurd, or you can email me, peter_hurd01@hotmail.com. I can provide this TDD simplified in 5 steps in a workshop format if you are interested, or if you just want to get in touch with me and you want some consultancy, then feel free to drop me a line. Okay, hope you've enjoyed this. Thank you very much.